conducting correlation, it's important to keep in mind the level of measurement of the variable that you're testing. In this example, we're going to look at the case of scale by scale correlation between two or more scale variables. And for this, we're going to use Pearson's correlation coefficient. In a moment, we'll look at an example where we have ordinal by scale or ordinal by ordinal, in which case we will use a different approach. For both, however, the command path is the same. In this example, we're going to look at the correlation between inequality and union density. We'll look at two measures of inequality, the Gini coefficient and the income share of the top 1%, and we will look at the unionization rate, the union density rate as well. The paths to do this is analyze, correlate, bivariate. From the window on the left, we're going to transfer over our three variables, which are Gini, top 1, and union. And you'll see here we've got a couple of options. A couple down here on the bottom left to specify which type of correlation. This is important when considering the level of measurement. By default, it's set to Pearson, which is suitable for scale by scale correlations. These are all scale variables, so each pair of correlations here that we look at in the table will be a scale by scale correlation. There are also several options. We can ask it to return a table of means and standard deviations. We can alter how it deals with missing cases. But we're going to leave these on their default at the moment. We'll change these settings in the next example. When you click OK, it gives us a table, and we can read any pair of correlations, coefficients, by reading down and across the variable name. So if we want to look at the correlation between Gini coefficient and union density, it's this intersecting cell here. If we want to look at the correlation between the Gini coefficient and the income share of the top 1%, it's this cell here. And you'll see here, if we're looking at the correlation between union density and the income shares of the top 1%, we can also read across to this cell here or to this cell here. So these are kind of mirrored above and below this axis. The correlation coefficient is given here in this cell. We also have a p-value, which allows us to check for whether the correlation is statistically significant. And it also gives us the sample size n, which is the valid number of cases given the deletion strategy that we've chosen earlier in the command path. So for guidelines on how to interpret these, you should refer back to your lecture notes for the tables of value ranges. And in this case, we would say this is perhaps a moderate to strong negative effect, and it's important to keep an eye on the sign as well. This correlation is negative, which means as Gini coefficient, as inequality increases, unionization decreases, and correspondingly. This one here, as we see, is positive, and it's quite strong. We would expect this anyway because these two are functionally related, but we see here that we have a positive correlation, which means that as inequality increases, so too does as Gini inequality increases, so too do the income shares of the top 1% tend to increase as well. These are often complemented with scatterplot matrices. So if you remember back to the graphing video previously, what we could also do here is to enter into Chart Builder and to produce a scatterplot matrix using the appropriate command down here. We transfer the appropriate graph up here into the window, and then we can drag all the variables that we want down here into this window. So again, I'm going to drag my Gini variable. I'm also going to select my top 1 variable, and then finally I'm going to select our unionization variable just down here towards the bottom. When you click OK, this will return for us a scatterplot matrix. And we can see here as well, if we read back up to our table, we see we've got a positive correlation between these two, and we see this reflected as well on the cell which contains the scatter plot for Gini and the top income shares of the 1%. Our scatter plot for union density and Gini is here, and our scatter plot for the income shares of the top 1% in union is here, and we can refer back to the table here as well to check the correlation scores. You can see from the direction here we've got a positive and we've got a negative in this case. But what about instances where the variables we wish to correlate are not measured at the scale level? A good example of this is, let's say we take two variables. First one here, internet use, which is measured on the scale level, and trust in the country's parliament, which is measured at the ordinal level. If we wanted to correlate these, we would violate the assumptions associated with Pearson's correlation coefficient, which is that both variables must be measured at the scale level. There are certain variables for which we can adopt this rule somewhat, and these are certain types of attitudinal measures or summed scales. But let's say in another example we wanted to look at the correlation between confidence in one's own ability to participate in politics and trust in politicians. So we wanted to see if there was a correlation between a person's belief in whether or not they were able to participate, and whether that in turn was associated with higher or lower levels of trust in political parties. To do that, we simply follow the same command path. It's analyze, correlate, bivariate. And again, I'm going to switch to variable names here. And the two that we're looking for are, first of all, this one here, this confident in own ability to participate, this CPT one that starts down here. So we'll transfer this one over to the right-hand side box. And the second one we're going to look at then is trust in politicians, which is given here by this TRST PLT. And we'll transfer that one over. Now what we need to do is that because we have two variables that are measured at the ordinal level, we just want to switch this one over here to Spearman, and we'll uncheck the Pearson's box. And when we do that, this returns to us a Spearman's row rank correlation coefficient. And we can interpret this in more or less the same way as we can Pearson's. We can interpret the effect size the same way. The Spearman's correlation coefficient will vary between 0 and 1, 0 to -1 for negative. And in this case, we see we have a positive, this 0.136. It's statistically significant, and we have a valid sample size of 2154. What does this mean? Well, what this means is that as confidence in one's own ability to participate in politics increases, so too does trust in politicians. They're positively correlated. Or we could say this, we can express this in multiple ways. Confidence in ability to participate in politics is positively correlated with trust in politicians. So those are the two procedures for generating correlation. Just be careful with your level of measurement. Check the variables first before you run the procedure, and make sure the correlation coefficient that you report is suited to the level of measurement of the variables that you're working with.